Hi, this is Mrs. Davis. This is AP Pre-Calculus. We are studying for the Unit 2B test, and this is the review. And we're on problems in the section 214, modeling. Okay, so we're doing our pH, and remember they give us, that's nice, they give us the formula for pH, so they just want us to calculate the concentration of hydrogen ions in moles per liter for a solution that has a pH of 7.7. So we're just going to say that we have that 7.7 is equal to negative log of H plus. So negative 7.7 is log of H plus. And then we can say, let's go 10 to the, so we'll put it in exponent form. So 10 to the negative 7.7 is H plus. So we can say that's approximately equal, using our calculator, 1.995 times 10 to the negative 8 moles per liter. So if they let you use a calculator, you can do that, but if not, just leave it as 10 to the negative 7.7. Calculate the concentration of hydrogen ions in moles per liter. So we're doing the same exact thing for this one. So we have 10.7 is equal to negative log of H plus. So negative 10.7 is log of H plus. So 10 to the negative 10.7 is H plus, or 1.995 times 10 to the negative 11 moles per liter. How many times greater is the hydrogen concentration of a pH of 7.7 than a pH of 10.7? So you would say, okay, I have 10 to the smaller negative number is bigger. So make sure you realize that. 10 to the negative 7.7 over 10 to the negative 10.7 is 10 to the third. You don't need a calculator for this. So that would be 1,000 times greater. Remember, when it asks times greater, you divide the larger one, the smaller one, by the larger one. How many orders of magnitude do they differ by? Well, orders of magnitude would be this guy, so that would be 3. All right, let's look at modeling set 2. So they're doing some regression in here, so you would put this into your calculator. So when I did it, I got f of x is 2.383 plus 3.423 ln x. And they're rounded to 3 decimal places because that was what they asked for. They want the model. So now they want to use it to find the value when x is 7. So we're talking about f of 7. And I use my y1 to store it. So it's 2.8383 plus 3.423 ln of 7, which is approximately equal to 9.043. So f of 7 is approximately equal to 9.043. Number 3, use that graph of the equation to find where f of x is equal to 7. So you're going to be doing this on your calculator, so you're going to say 7 is 2.383 plus 3.423 ln of x, and you're going to make 7 y1 and that side of the equation y2, and look for the intersection, so you should get x equals 3.853. And what's the residual for the point 2, 4.7? So let's refresh ourselves. The residual is the actual minus the predicted. So this is the actual, so this would be, well, first let's find out what f of 2 is, because we're talking about at the input value 2. So f of 2 using your calculator with the same regression model is 4.755643. So the residual would be 4.7 minus 4.755643. so it's equal to negative 0.056. All right, let's move on to the last set, 215. Semi-log plots, then we'll be done with this review. So they want you to, they give you a cable of XY values, and they say it can be linearized. This must be a exponential, so they want us to take the ln of y to linearize it for a semi-log plot. So just put in ln of 0.3 and do that for all of these. So this would be negative 1.204, negative 0.400, 0.405, 1.215, and 2.020. So find x ln x, and then they want the linear regression model. So in the linear regression model, you're going to use this data, the x and the ln y. And so if you put that in and use linear regression, watch out, because you're doing the line, right, the linear. You're going to have that, and it's for ln y, so ln y is equal to 0.806x minus 1.205. So that's the linear model. Now, use your model to find the y value when x is 6. So ln y is equal to 0.806 times 6 minus 1.205. So you should get ln y is equal to 3.633 from your calculator. And now you've got to solve for y. You have ln y. So this is e to the 3.633 is y, and that's approximately equal to 37.826. Number 4 says use your regression to find an exponential equation to model the original data set. Okay, so I have just taken e to the 0.806x minus 1.205, and then that can be e to the 0.806 times e to the x. No, I did that wrong. Hang on. Go back down there. It's to the x. Like that's to the xx. That's not adding. That's bad to do. So this to the x. And then it's minus, so times e to the negative 1.205. So you get y equals, and e to the 0.806 would be 2.239 to the x times e to the negative 1.02 is 0.300. So rewriting it the way we usually write it, we write y equals 0.300 times 2.239 to the x. All right? Now this one is exactly the same thing, so you should really just try to do this all on your own. But I'll put down the answers so you, but you should notice this was ln, right? So you had to use ln when you were using like the e's and stuff. And so when we're calculating this, you had to use ln of y. And now we're using log of y. So put the log in or you'll get different answers. So 1.079, 0.911, 0.741, 0.573, and 0.405. If you take these two in linear regression, you're going to get log of y is equal to negative 0.169, remember linear, x plus 1.079. So we would say we want to know what it is when it's 6, so log of y would be negative 0.169 times 6 plus 1.079. So log of y is equal to 0.067. And so 10 to the 0.067, because now we're using not e but log, so equals y. So if you do that in your calculator, if you can use it for this, y is approximately equal to 1.168. And very last question, use your regression to find an exponential equation. So instead of e now, we're going to say, okay, we're going to use the base of 10 to the negative 0.169 quantity x, right, times 10 to the 1.079 is equal to y. And so let's do this first. Y equals 11.995 times put that in the calculator. That comes out to be 0.678 to the x. Whew, okay, we got through the whole review.